Right. So next characteristic, silent feature of Mendeleev's periodic table is it is simply about correction of atomic weights. So here they don't know how to calculate that atomic weights. So simply they based on the property. Sorry, it is a principle simply, right? Equivalent weight and valency product, right? So they used a formula. Maybe they thought valence is wrong. So Mendeleev periodic table helped in correcting the atomic weights, right? Mendeleev's periodic table helped in correcting the atomic weights of the element. So simply that atomic masses like beryllium, indium, gold are corrected by Mendeleev. Beryllium, indium, and gold. So here, atomic weight of beryllium was given as 13.5 at that time, but not 13.5. According to the chemical properties, that element fall into the group, second group. So that similarities of the elements like calcium, magnesium, etc. are there. So that atomic weight is calculated by using the formula is equivalent weight and valency. Is equivalent weight and valency. Right? So here, that valency of the element beryllium should be 2 because that properties of the element are similar to the second group elements, magnesium and calcium. So that is the reason to decide that atomic weight was given as wrong. So beryllium atomic weight should be 9 according to equivalent weight and valency. So equivalent weight found as 4.5 units. So 4.5 into 2 will be given as 9. So not only these beryllium, he also helped in correcting the atomic weights of indium and gold using the same method. Equivalent weight and valency concept. Then the last silent feature is here anomalous series. What the periodic law was given by Mendeleev. Here, physical and chemical properties of the elements or the periodic functions of the atomic weights. They are arranged in the increasing order of atomic weights. Right? Elements are arranged in the increasing order of atomic weights. So that he thought. But here, when you observe that periodic table, you will find anomalous series. That means here pairs of elements in which the increasing order of atomic masses or weights not obeyed. Increasing order actually. Just a second. Yeah. Here simply anomalous pair meaning is the pairs of element which are not in the increasing order of atomic weight. Pairs, group of 2 elements, combination of 2, right? So was not obeyed. Was not obeyed. So that anomalous series is observed. Anomalous series is observed in the Mendeleev period table. So that minor inversions, they are accepted by Mendeleev actually. So what that we need to observe. So example here, tellurium atomic weight is 127.6 units. Then one more element is there, iodine 126.9 units. So according to periodic law, in the increasing order of atomic weights, iodine is expected first and tellurium is next. So iodine first, tellurium is next. Iodine first, tellurium next. But what we are observing in the Mendeleev's periodic table, you are going to observe that tellurium is first and iodine is followed by tellurium. Right? So iodine is next. So first tellurium and next is iodine. But according to periodic law, iodine is first and tellurium is next. So it is a contradiction. It is not obeying the periodic law, not increasing order, not in the increasing order. So this is the reason here. So tellurium was placed before the element with less atomic weight, before iodine. So this is called anomalous pair. So these are the minor inversions that which are accepted by Mendeleev. But the positions of these two elements are correct. Tellurium and iodine, they are placed in the right slots. Right? Then what the reason for placing of that elements in such places? Right? So these are accepted by Mendeleev. So then we are going for the limitations of Mendeleev's periodic table that are given in the page number 130. So 131. 131. So Mendeleev's periodic table, just little minor inversions are there. We are discussing here. So what are the minor inversions? Anomalous pair of elements. What is anomalous pair? That will not obeying the increasing order of atomic weights, not in the order of increasing order of atomic weights. Right? Not in the order of increasing order of atomic weight. So that's why they are called as here anomalous pair. So tellurium atomic weight is 127.6 and it is precedes iodine. Atomic weight is 126.9. So this is minor inversion. Right? So anomalous pair we are writing as one of the limitation. Then dissimilar elements are placed together into the same group. So what they are here? Simply chlorine. Chlorine is a gas which is placed in the 7th A group. But in the 7th B group, we have manganese, which is a metal. So how they are similar? So dissimilar elements are placed together. So this is also accepted. Then the other also I'm discussing here, which are not given in your textbook, right? So which are not given in your textbook, that also I'm discussing. Some similar elements are separated here. What the similar elements, for example, here, similar elements like copper and hydrogen, silicon and tellurium, they are placed in different groups of the periodic table. Actually, that are similar in chemical properties or valencies, but they are placed in different groups. Why they are? What may be the reason for placing the elements into the different groups, separating them, right? So this is similar elements are separated. Then one more also I'm discussing here, position of hydrogen, right? Position of hydrogen. That is completely a gas which is placed along with the 1A group called alkali metals or alkali earth metals, 1B group. Right? So simply, sorry, alkali earth metals only, not alkali, no, alkali metals, not alkali earth metals. Alkali earth metals are second group elements, right? So here, that position of hydrogen in the table is not suitable because it is placed in a 1A group. Actually, that properties of the hydrogen was similar to 7th A group elements, right? Right. So this is a small minor inversions are observed in the Mendeleev's periodic table. So this is the reason for going further classification due to these minor inversions. Due to this minor inversions. So after completing this, we are entering into the another that is here simply modern periodic table. So before that, you have few topics that are given in the boxes as do you know. So what they are here in the do you know concept, we are discussing about Mendeleev predictions. So predictions are already given for the Eka aluminum and Eka silicon. So while he predicted, how he is given that prediction simply here about Eka aluminum. When I hold that aluminium in my hand, it was melt. It will melt. So simply he said about the melting point of the aluminium. What is our body temperature? 37 degrees Celsius. So melting point of the aluminium, aluminium was predicted as lower than 37 degrees Celsius. Lower than 37 degrees Celsius. That melting point of gallium is observed as 30.2 degrees Celsius. So lower than body temperature. So when you hold it, what happens? It absorbs the heat energy from your body because of your body temperature, 37 degrees Celsius temperature, it can melt. So that accurately he predicted. Then one more here we need to know, that is Mendelevium. Element 101, element number 101 was named as Mendelevium here to honor the scientist Mendeleev. So to honor Mendeleev, that 101th element was named as Mendelevium. So these are the 7 features and limitations of a Mendeleev periodic table. So this is Mendeleev periodic table, right? So predictions are given. Predictions are given, right? So here simply aluminium, it is below aluminium with the 44 atomic weight, right? So like that, he predicted and he allotted slots. So many empty slots are given in the periodic classification, right? So 7 periods said, but 12 periods, 12 horizontal rows are taken here. Why? Not suggested, right? So like these minor inversions are there, that minor inversions are corrected in the next periodic classification, that is modern periodic table. So successfully that elements are arranged into the groups and periods. So that we'll discuss tomorrow here, right? That we'll discuss by tomorrow.